Now let us see what is happening over here. I have defined a function which takes two elements as parameters. You can see there are two values a and b. These are called parameters, or strictly speaking they are called arguments. So these are called arguments or parameters. This is to take values from outside the function environment. So if we want to pass some values from outside the function environment, we use such arguments or parameters. So we have two parameters over here named a and b. What I am trying to do out here is I am trying to find the sum of the two parameters and store it in C. Next, I am displaying the value of C. Now look at the main function. This is very important. I have over here function called fun 5, 6. So what I am doing is this time, since we have two parameters, we need to pass two values to those two parameters. So I am passing 5 to the first parameter, that is variable a, and 6 to the variable b. So the value of a and b is 5 and 6 respectively. So c equal to 5 plus 6 will give me 11. So print sum equal to c will definitely display sum equal to 5 plus 6, that is 11. And after that, once again, the execution comes to the next line. And function 7, 8. This time 7 goes to variable a and 8 goes to b. So it goes corresponding values to the corresponding variables. And now 7 plus 8 is 15. Print sum equal to c. So it's going to print sum equal to 15. See how simple it is for adding the two numbers out here. We call it repeatedly more than once, and every time we do that, we pass two values because it has two arguments or parameters to be received from the function, from the main part. Now, every variable that you declare inside a function, its scope is limited only within that function. What do I mean by that? Suppose, say for example, I have something like this. Now look at this function definition. I have a local variable named a, which is initialized with the value 7. Now this is local in the sense that its scope is only limited within this function named func. I also have a variable named a, which is initialized with the value 9, whose scope is limited only outside the function, that is out here only. Now you can see what is going to happen. The program execution begins over here. A equal to 9, print a, so definitely it's going to display 9 as the first output. I'm making a function called func, so the control gets transferred over here. A equal to 7. This a has nothing to do with this a. This a is local to this function. It occupies a separate memory location. Print a, so definitely it's going to print 7. Now when it gets back to the next line, print a, here the value of a is still 9, so it displays 9. In case it is necessary to share a variable to all the functions, you may have multiple functions in a program. If you want it to be shared by all functions, then we use a global variable. That means we use a variable which is defined at the top. So suppose I write over here a equal to 9 instead of 8. Now let's see the difference. You see over here a equal to 9 indicating that it's global. In other words, it is being shared by everyone, the functions as well as the main segment of the program. Now you see what happens is print a, so the value of a is 9, so therefore it displays 9. I make a call to the function named function, so it comes over here, print a. Before doing that, let me do something. Let me change the value of a to 7. So it's going to print 7. Whenever we have a variable named a inside a function whose name matches with the global variable, this occupies a separate memory location. So print a is going to display 7 because the value of a is still 7. So therefore, when I print a, it's going to print the global a, that is, it's going to print 9. So what actually happens is, if we have a same variable whose name is same as the global variable, it gets more priority and therefore it prints 7. Although it looks like that this a is actually changing the value of this a, but this is not. It is occupying a completely separate memory location and this a is local to this function only. However, in case we needed to mean that this a is actually the global variable a, we need to use the global keyword. So what we do is, we write it this way, global a. Now any reference to the variable a actually means the global a. So here when I write a equal to 7 and print a, now see the difference in output. We begin from here, print a, so it's going to print 9. Function call, it comes over here. Global a, that means any reference to the variable a means the global a. So a equal to 7. So this a changes to 7. So print a, it prints 7. Now when I come over here, print a, since the global variable a has changed to 7, it's going to definitely print 7. So this is how it works. Therefore, all local variables are localized to that particular function only. In case a variable name matches with the name of a global variable, it gets more priority inside the function. Any reference to that variable means the local variable. In case we need to refer to the global variable, what we do is we use the keyword global followed by the variable name. And therefore, any reference to that global variable is reflected out here also in the main function.
Okay, so you can see once again I am starting with the sharing my screen, and here I am using the Python ideally once again, and this is in the remember this is in the interactive mode, the shell window, and here we have the script mode where we are going to write the code basically. So this time once again I'm going to demonstrate how do we pass values to a function. So same thing, whatever I have done on the board, I'm going to show you once again on the computer. So we'll begin with the def keyword, and let me do the same program. That is, I'm going to find the sum of two numbers which I'm going to pass as parameters or arguments. Okay, let me name it as sum, and I'm going to pass two values, say a and b, followed by a colon to mark the beginning of the block of the function. C equal to a plus b. I'm going to add it, and I'm going to display the value of c. That is sum equal to comma c. So this is what I'm going to do, and here we are going to start with the main part of the program. Remember, we are following a convention where wherever we start the main part of the program, we are going to begin with a comment main, though it is not necessary, but we are following this convention to make things look easier to understand. And here I'm going to invoke or call the function sum, and I'm going to pass two parameters, say 5 and 6. So 5 will go to the variable a and 6 will go to variable b. This I've already discussed. C equal to 5 plus 6 will get added, and sum equal to 11 will be displayed. Let's try running this program. Run module. Okay, you must save the program first in Python ideally. Okay, let me name it as demo2. Okay, click on OK, and there you can see the output sum equal to 11. This is what is happening over here. Now let me tell you that the value 5 and 6 which you are passing while invocation of the function, that's called the actual parameter, and this is simply a technical name. You need to remember this, and the function accepts these values with the variables a and b, which you can see within the parenthesis. These are called the formal parameters, or formal arguments. So from now onwards, whenever I invoke and if I pass values, we'll call it actual parameters or actual arguments, and the function where the variables which are enclosed within the parenthesis in the function definition, we are going to call that formal parameters. So formal parameters are to accept values and actual parameters are to pass values. So that is the basic idea behind these two names. Now what I'm going to do is I'm going to instead of passing literals, that is 5 and 6, that is constants, to the formal parameters, this time I'm also going to pass the value of variables over here. So let me initialize the value of variables, say a equal to 5. I take a variable a equal to 5, initialize with that, and b equal to 6. Now let me be very clear out here that this AB has nothing to do with this AB. This AB is local to this main area of the program, and this AB is local to the function named sum. They do not interfere with each other. So please keep that in mind. Whenever you come out of the function, all variables which are localized to that function will get completely wiped out of the memory. So this AB has nothing to do with this. So certain students, there are students who ask me that whether I should be giving the same name. It is not necessary. You can give any name for the variables which you are going to pass as actual parameters. Now let's see, we'll pass these two variables. So sum a comma b. So this time what happens? 5 goes to, you can see the value of A is 5. So this 5 goes to this formal parameter A, 5, and the 6 goes to this formal parameter B. So C equal to 5 plus 6, and once again I'm going to get the same output, that is 11. Okay, let me change a bit, say 15 and 16. So just to create a difference in the output, I'm doing this. Okay, let me run the program. Okay, it's asking me to save it. Let me save it. And there you can see sum equal to 11 is the output which we got in the previous case. So it still continues to show me the same output, and sum equal to 31. So this is because 15 and 16 this time got added. What is important out here is it's not just constant. You can also pass variables to it. And the variables need not be the same name AB. It may be different from the formal parameters. In any case, it's actually different from each other. So this time I'm going to demonstrate, I'll take two different variable names and pass, values to it. So x and y equal to 10. Let me do that. And I'm going to call or invoke the sum function. So this time passing x and y respectively. So now let's run the program once again. Run module and okay. There you see sum equal to 22. This is what we got. Even when I have a different name, still it works. Remember, the local variable is local to that particular part wherever you are declaring it. So this is what is happening over here. Now let me illustrate this further. What I'm going to do is I'm going to instead of initializing variables or passing constants to it, what I'm going to do is I'm going to accept user input, and that is what I'm going to pass over there. So let's try that. Say I'm going to use the variable x equal to int, and then input, a simple input statement where I'm going to enter a number. This message is being displayed, and then y equal to, once again, int input, enter another number. So this is what I'm going to do, and here I'm going to invoke the sum function, sum x comma y. Let me see what is going to happen this time. Run module. Okay, we need to save it, and here you can see the first thing what we get is enter a number. Okay, let me input a number, say 13, and enter another number. Let me enter, say 24. So this time what am I going to get? Okay, sum equal to 37. This time 13 and 24, which was inserted into the variables x and y, which gets ultimately passed to the variables a and b, and 13 and 24 adds up to give us 37. So sum equal to c, so it's displaying sum equal to 37. So this is what is happening over here. And remember something that you can also pass mathematical expression to a function. You can even pass the actual parameters which you're going to pass, maybe an expression, and the formal parameter is going to accept this mathematical expression. I'll give a demonstration. Say let me remain the same thing, or let me modify this. So this x and y, whatever the user inputs, I'm going to add 1 to it and then pass it. What I want to do is I'm passing basically a mathematical expression. That is, it need not be a single variable out here. It may be an entire calculation which you can pass as actual parameters to the formal parameters. Let's run this once again, and okay. So this time I'm going to insert 5 for x and 6 for y. So 6 gets passed to variable a because I add 1 out here, you can see, and pass it to variable a, and I am going to pass 7 to variable y, which ultimately goes to variable b. So 6 and 7 when added will give me 13. So this is what we are getting. Hence the output sum equal to 13. The answer is quite obvious. Okay. Now, I believe you understood this. Now, you may have several functions. This is in the first class itself. I have already discussed. You may have multiple functions inside the same program. Okay, let me do something. I'll give you a demonstration. I'm going to, create another function difference where I'm going to find the difference between the user entered values. So I'm going to find the sum as well as I'm going to find the difference. So let me do this. Difference, the same thing, a comma b, and then C equal to A minus B, and then I'm going to print the difference. Print difference equal to a small message. This looks better. Difference equal to C. So this is what we are going to do. And here, let me get back to the normal, variable passing or actual parameter passing instead of mathematical expression. And I'm also going to call the difference function difference x comma y. Okay, so that is what we can do. Let me run this particular code. Let's see what is going to happen. Okay, so we are going to enter the first number, that is 25, and another number, say 12. So the sum function is going to definitely add it, and difference function is definitely going to subtract. So what is the answer we get? Sum equal to 37 and difference equal to 13. So the answer is quite obvious, you can see. So this is how we can invoke the function, different functions with the same parameters. So this is what we are seeing out here. Now what I'm going to do is I'm going to show you how this the concept of global variable, which we learned on board. So we are going to see the concept of this local variables and global variables. Okay, let me start with the simple. Just remove this, otherwise it will become too difficult for you to understand. So here we are going to begin with def, and okay, let me name the function as fun. And here, say I'll be creating two functions, say fun1, and here I'll take a variable, say a equal to 10, and I'm going to display the value of a, and then I'm going to subtract 2 from this, that means making it 8. However, I'm going to exit from this function. Now I'll make one more function. This is a very interesting program which I'm going to illustrate you regarding functions. This is 25 and print a, and once again I'm going to deduct 2 from this variable a. And in the main part, following the same convention of writing main, though not necessary, remember, out here what I'm going to do is I'm going to invoke the fun1 function as well as the fun2 function. This is what it is supposed to do. Let's see what it is supposed to do. So during the first invocation, fun1, what happens is a is being initialized with 10, and please remember this variable, whatever is being initialized, is local to the fun1 function. It has nothing to do with any occurrence of variable a in some other function. So this a is exclusive to the fun1 function. Keep this in mind, because this is the variable name which it comes across for the first time in the function. So fun1 a equal to 10, so the value of a will be 10, and now what I am doing, print a, so definitely it's going to print 10, and then I deduct 2 from it. So this a, that is the a which I've defined or declared or initialized rather or assigned in variable fun1, is deducted by 2 and 8. However, it doesn't make any difference, because once I come out of the function, this a which you have declared in fun1 function gets completely wiped out. So whenever you are calling fun2 function, there is a new a which is being created, which is being initialized with 25. Print a, it's going to print 25, and it's not going to print 8 or anything of that sort, because it's a new variable which is being declared. And a equal to a minus 2, it becomes 23, but it doesn't make any difference. Okay, now to make things more look better, so what I'm going to do is I'm going to take one more variable out here, and I'm going to put 30 out here, and here I'm going to display a, and even out here I'm going to display the value of a. Now what actually happens is a equal to 30, print a, it's going to display 30. Fun1, it comes over here, this a which has nothing to do with this a, print a, it's going to print 10. This a gets deducted by 2, so this a becomes 8. However, when you come out of this function, this a gets wiped out of the memory. So fun2, again there is a new variable a which is being initialized with 25. It is going to display 25, no doubt regarding it, and then we deduct 2 from it, so we are going to get 23. And after that, once you come out of the function, this a which was initialized with 25 in fun2 function, even this gets wiped out of the memory. So print a, and in the main area, this variable a was being initialized with 30, so it still remains 30. and therefore it's going to display 30. So let's see whatever I have said, whether it matches or not. Run, let's run the module. Okay. And there you can see exactly this is what happened with our program. So same thing, even if I take this variable as global, remember a variable when initialized outside all the functions before it becomes global. So let me cut paste this at the top, very top of it, and see what is the output which we are going to get. Okay, let me run this, of course, after saving. And here, if you look at the two outputs, it's exactly same. The reason behind this is once actually what happens, print A, it's going to display the global variable A's value, that is 30. Fun1, it comes over here, A equal to 10. Now remember, it seems that this A, which was global in nature, is being initialized with another, which is being, it's being assigned with a new value that is 10, but nothing of that sort happens uh, out here. If you're coming from a background like C or C++, you know that global variables, can be, modified in any of these functions. You must have already seen this. But in Python, nothing of that sort happens. Even if we have the variable with the same name, it will be taken as a new variable and local to this function only. So no question of that global A getting changed inside the fun1 function unless we specify that. So what I'm going to do now is I'm going to specify that is I'm going to use the keyword globally. So once I write globally, you know that every occurrence of the variable A means the global A I'm referring to. And fun2, I'll keep this as local. So A equal to 25, which is in fun2, it will remain as local. So let's see what is going to happen. So what is going to happen, let me tell you right at the beginning, and then we are going to see whether the output coincides with what I'm telling or not. So print A, it's the first thing it's going to print is the global variable 30, no doubt regarding it, because there's no local A to the main part. Fun1, so I'm invoking the fun function. So fun1 out here, what happens is I'm calling the global variable. So global A, which was 30, is now being assigned 10. So print A, it's going to print 10 out here, and then the global A is being deducted by 2, so it will become 8. Now fun2, this is altogether, the local variable, so it will be 25 and A becomes 23. However, it doesn't make a difference because fun2, once you exit, the local A gets wiped out of the memory. However, when I print A, it is going to print the value of A which was last modified in the fun1 function. And remember, what was it? It was 8, so it's supposed to display 8. Now let's see whether it works that way or not. Run and save it, and let's see. Yeah, it works exactly the way I had talked about it. So this is how the global variable plays a key part in executing our program. So you must be having a clear concept because you get a lot of output related to this. After this, I have given a lot of assignments, and I expect you all to do these assignments and post it in my mailbox. Thank you.